Hello again, I'm your guide, Engineer Mikko de Torres, and in this video, we're delving into the heart of our journey. We'll explore the true meanings of robotics and mechatronics and also clarify the distinctions between these two vital concepts. Let's jump right in. Let's unravel the essence of a robot. Back in 1979, the Robot Institute of America painted a clear picture. A robot is a reprogrammable multifunctional manipulator. It's designed to gracefully dance through a variety of programmed motions. Imagine it moving materials, parts, tools, and even specialized gadgets, all with the purpose of accomplishing an array of tasks. While from Webster's interpretation, it adds a unique twist. According to them, a robot is an automatic device. It takes on roles typically associated with humans or machines, often with a human-like flair. Now, we'll delve into the captivating world of robotics and explore its intricate and varied definition. According to the International Organization for Standardization, robotics is a vibrant interdisciplinary field. It mirrors mechanical engineering, electrical engineering, computer science, and more. Imagine a symphony of disciplines coming together to create, design, construct, and operate robots. And it doesn't stop there. Control systems, sensory feedback, and information processing are also part of the grand orchestra. Then, the IFR defines robotics as the science, technology, and application of robots. A mechatronics marvel, it blends mechanical and electrical engineering, computer science, and related fields. Robotic crafts, robotic crafts operates and integrates robots into applications like manufacturing, healthcare, logistics, and more. Now let's break down the foundations of robotics and mechatronics engineering in a nutshell. Robotics engineering is the art of crafting machines that mirror human actions. It's about bringing technology to life, designing robots that can perform tasks we do, think, and imagine. While mechatronics engineering is the symphony of precision, mechanical engineering, electronics, computer systems, and advanced controls. It's the fusion that makes our technology not just smart, but seamlessly integrated and responsive. In essence, these two disciplines pave the way for innovation that dances between replicating human actions and advancing the capabilities of technology. Let's dive deeper into robotics and mechatronics engineering to understand their new. In the world of robotics engineering, the keywords are replicate human actions. Here the focus is on creating machines that mimic human tasks. Notably, a robot doesn't always need an electromechanical component. It's about achieving the desired action regardless of the form. Turning our attention to mechatronics engineering, the keywords are integrates. Importantly, a mechatronic system doesn't always revolve around designing a robot. It's about creating cohesive systems that seamlessly blend various components. In a nutshell, robotics and mechatronics engineering are versatile fields that encompass a wide range of possibilities, from replicating human actions to crafting integrated systems that enhance technology. Let's bring our exploration of robotics and mechatronics engineering to a culmination with some insightful distinctions. Robotics engineering, while is indeed a subfield of mechatronics, it holds an elevated status within this domain. Robotics can be considered an advanced class of mechatronics, dealing specifically with the creation of intelligent machines that replicate human actions. Delving deeper, we grasp a fundamental truth. All robotics are mechatronics, but not all mechatronics are robotics. Mechatronics encompasses a broader spectrum of integrated systems, while robotics hands in on the creation of dynamic, human-like machines. In essence, these disciplines are intertwined yet distinct, each contributing its unique essence to the captivating world of technology. And through these lessons, we will both doing robotics and mechatronics designs.